Hello, guys. So, this is a new question. This is question 3, the third question from those revision questions, that big document with 20 questions in total. Okay, so we are looking at a new question, and this will be a binomial question. So, let's have a look. Terry purchases small pack of Narcissus poeticus seeds. So we're talking about seeds. The seed packaging claims that the germination rate of the seeds is 75%. Terry sows 5 seeds selected at random in his backyard. Okay. A. Find the probability that at least one seed will germinate. So what are we looking at? We've got this Terry boy, and he has 5 seeds. Yeah, so he's gonna sow 5 seeds in his backyard. And we are looking in the first place for the probability that at least one will germinate. Okay, so how are we gonna do that? Well, we're gonna have a look at what is given. So a certain probability is given. We know that we have 5 seeds, and we're looking for the probability that at least one will germinate. So now you can recognize a binomial distribution. And why? Let's have a look at binomial again. What was binomial again? So if we have a binomial distribution, we can have a look at 2 outcomes. So we have a success and we have a failure. Okay, so that is binomial. And we denote x, the random variable, and x will be the number of successes. Okay, number of successes. And then we can, for example, look at the probability that x is something, like k or 3 or whatever. And that will be the probability that the number of successes is k. So if you remember well, I introduced the binomial distribution with this crush, that you had a crush and you would text this person 5 times a week. Every day you would text him or her, and there was a probability of success. So the probability of success was 40% because he could reply or he could ghost. And replying was a success rate of 40% probability. And ghosting was 60% of the time. Okay? So success in that case was your crush is going to reply to you. And failure is your crush is not going to reply to you. And then we had denoted, like, what we were wondering, what was the probability that he was going to answer exactly twice in a week. So that would have been like this. Remember? So the number of times that he replies would be 2. So this is a binomial. Okay, so let's have a look at this case. What is our success? Well, we're looking for the probability that at least one seed will germinate. So at least one, that will have to do with this k, like what do we want the number of successes to be? But what is the success? That's that seeds will germinate. So we are going to write down a seed will germinate. Okay. And a seed will not germinate. So that is, with the binomial, we've got 2 events, 2 outcomes. All right, so now we are looking for, with binomial, we would say that x is binomially distributed with a certain n and a certain p. And we write it down like this. And what is this n? That's the number of trials. Number of trials. So in my example with the crush, we were sending this crush a message 5 days a week. So n was 5, remember? And p is the probability of success. So the probability of success with my crush was 40%, because every time you text this person, there's a chance of 40% that he's going to reply. So let's have a look. In our case, Terry sows 5 seeds, and we are looking for the probability that at least one seed will germinate. So in our case, n will be 5, because we have 5 seeds. and we want at least one to germinate, okay? So N is 5, and P is the probability of success. So what is the probability of success? Let's have a look together. So the outcome of success is that a seed will germinate. So what is given, guys, then you have to be careful with what is given. Terry purchased a small pack, blah, blah, blah. The seed packaging claims that the germination rate of the seeds is 75%. So a seed will germinate in 75% of the cases. So basically P will be 0.75. You see? And failure, we will not need it here, but failure is denoted by Q, and that's 1 minus P, and that is therefore 1 minus 0.75. That's 0.25. But you don't really need to write it down, you just have to know this stuff. Okay, so we know now that X indeed is binomial distributed. What is X in our case? X will be the number of seeds that germinate. Yeah? Why do we say that? Because we're interested. We are interested in the probability that at least one seed will germinate. So we're going to denote X by the number of successes. That's always the case with binomial. And then we're going to have a look what was success again. That is that a seed is germinating. So X is the number of seeds that germinate. And therefore X is binomially distributed with an N and a P. And in our case, that is 5 and 0.75. Right? Because the rate of the probability of germinating is 0.75. Okay, so this is the hard work. If you have figured out this stuff, guys, then you're on the right track. This is great. So write this down in your tests. And we also want you to write down this. Like we have to denote X, and we want you to write down that it's like the number of successes. So in this case, it will be the number of seeds that germinate. This, you don't necessarily have to write it down, but it's good for you to know. But this is the crucial stuff, okay? Okay, and then, now we've denoted our random variable that is binomially distributed. So now we can have a look at the question. So, what is asked? Find the probability that at least one seed will germinate. So basically, now it's quite simple. We're just going to say we're looking for the probability that X is bigger or equal to 1, isn't it? Because X is the number of seeds germinating, right? So, and X is binomially distributed. So we're just going to say X bigger or equal to 1. Great. And then we simply use the calculator, because that is going to do your work here. That's awesome. So you use this, you go for binomial. And now the question is, are we going to use PDF or are we going to use CDF? So PDF is when you're looking for the probability of X, for example, is equal to 3, like a single value. CDF is when you have a range, when X is, for example, bigger than 1, or when you say X is between 7 and 2, for example. So remember, PDF is for one value, CDF is for a range. Okay, so what are we going to do here? Well, as we are interested in the probability that X is bigger than 1, we are going to do CDF. So we are going to do CDF because you could also have done it manually, because this is actually the P of X is equal to 1 plus the P of X is equal to 2 plus And what are the values of X? Number of seeds germinating. So X, we have 5 seeds in total. So X will be either 0, 1, 2, 3, 4, or 5, right? So we would go all the way to Px is 5. And then we would use the PDF in this case. And we would do this calculation with the calculator. But that's a lot of work. And your calculator helps you out. So you don't do this manually. You don't have to. You simply use the calculator and it does the work for you. So the calculator is going to add all those probabilities. And then you simply have to put your CDFs. So what do we need? We need the n, your p, your lower bound, and your upper bound, right? Okay, so n is 5, p is 0.75, right? Because this is how we denoted our x. X is binomially with an n of 5 and a p of 0.75. So, and then what is our lower bound? So we're going to take the range for x is equal to 1 up till x is equal to 5. So lower bound is 1 and upper bound is 5. Okay, great. So you put this in your calculator and then the answer comes out and you will have that px is equal or bigger than 1 is equal to 0.999. Okay, so this means that it's almost chance 100% that at least one seed will germinate. Okay, so Terry is going to be happy. All right, so this is the answer to question A. So this is really a basic binomial distribution question. So practice with this, guys, to feel comfortable with how it works. The key here is to recognize a binomial distribution because we're kind of looking for a probability of a number of successes. And for a number of successes, we need to denote what are the successes and we need a probability of success. You see? Okay, and then what is B? Find the probability that exactly 3 seeds will germinate. So this is a bit simpler. We just write down p x is equal to 3, right? Because x, again, is the number of successes or the number of seeds that germinate. And therefore, we are going to use our calculator. So, guys, is this, now the question is again, is this a binomial PDF? Oh, PDF? Or is it CDF? Well, as we saw just before, CDF is with a range. It's, for example, bigger than 1 or whatever. PDF is when we have a single value. So, you're going to put this in your calculator and you're going to use the PDF function, PDF. And for PDF, you need a few things. N again, P, and the value. So, N, we did it already, is 5. P is 0.75. And the value, what is our value? The value is this one guy. This we want x to be 3. Oh, right? So our value is 3. And then you put this in your calculator. And then what comes out? This will be, oh, let me just do that again. This will be approximately 0.264. Right? So this actually means that 26%, there's a 26% chance, 26.4% chance that we will have exactly 3 seeds that will germinate. So 3 seeds out of 5 will germinate, and that is a probability of 26%. Okay, so this is how we do binomial, guys. Okay, so recognize CDF and PDF. CDF is with a range when the calculator does the work for you. So instead of just adding all those PDFs, x is 1, x is 2, you just say x is bigger than 1, bigger or equal to 1. And then you say lower bound and upper bound. And if you have just one single value, you use the PDF. And you just give one value, which is 3. Okay, I hope this helps. See ya!